Hello everyone, we are going over the last part of our factoring flowchart. So, little reminder, remember that we always start off with the GCF. No matter what kind of factoring problem we think it might be, the GCF always has to happen first. Sometimes there's a GCF and sometimes there's not. If there is one, you factor it out. Then you ask yourself, how many terms are there? So we've already discussed when there's two terms, it's a difference of two squares. It's a something squared minus a something squared, and you get a plus and a minus binomial. We've discussed three terms, a trinomial, where if a is 1, you only need the diamond, but if a is not 1, you need the diamond and the box. Today, what we're going to be talking about is if there's four terms. Now for four terms, it is factoring by grouping. There's two methods I'm going to show you. One of them is underlining and one of them is the box method. The box method actually looks very much like the box that we use with trinomials. So the way this is going to work, if you see that you have four terms, you choose the method that you think works best for you. If you choose underlining, and I'm going to show you both, first thing you do is you underline the first two terms, terms 1 and 2, and you factor out the GCF. Then you underline terms 3 and 4, and again you factor out the GCF. When you've done this, the parentheses should match. So that's part of your answer. The second set of your answer is collecting those GCFs in their own set of parentheses. So I'm going to do problem number 1 like that. The other way is you make a box. You place all four terms into a 2x2 box and you factor the GCF of the rows and columns. So I will show you both methods. So number 1, we have 12a cubed minus 9a squared minus 4a minus 3. So I'm going to underline terms 1 and 2. The GCF is a 3 and an a squared. Remember that you can only take the lowest of the exponents out. So that is multiplied by then 4a minus 3. Then, I fixed this earlier and then it unfixed it for me. For the second part, we underline terms 3 and 4. Now, if you look at terms 3 and 4, they don't have a whole lot in common. However, there is a negative with the 4a and a positive with the 3. But if I look ahead, what I would really like to have is this set of parentheses match. We also had discussed that if your first term is a negative, you factor out a negative 1. So I'm going to factor out a negative 1. What that gets me is a 4a minus 3. Now what I'm going to notice is that my parentheses match, as I said that they should. So that's part of our answer. Part of our answer is that matching set of parentheses. In the second set of parentheses, I'm going to collect my GCFs. So I have a 3a squared and I have a negative 1. And that is your factored answer. Okay, let's try another one. Problem number 2. We have 12x cubed plus 4x squared plus 3x plus 1. Now for this one, I'm going to show you the box method. So you make a 2x2 box. And in the box, you put your terms. 12x cubed, 4x squared, 3x, and a plus 1. If I had chosen to switch where my 4x squared and 3x are, we'd still get the same answer. Actually, any of them really could get switched. So if I factor out the GCF of the first column, they have a 3x in common. If I factor out the second column, it has a 1 in common. The top row has a 4 and an x squared in common, and the bottom row has a 1. So now, if I just look at the sides of my box, I have my answer. I have a 3x plus 1 on the top and a 4x squared plus 1 on the side. So that's my factored answer for that four-termed polynomial. Okay, let's try one more. This problem, I'm going to do the factoring by underlining. So the first two terms only have an x in common. So if I factor that out, it's going to be a 4x squared minus 1. The second set of terms 3 and 4, have a 3 in common. And if I factor that out, I get a 4x squared minus 1. which is perfect because since my parentheses match, remember this is the only way this happens, I can say that my answer is 4x squared minus 1, which is the matching part, and the GCFs, which is x plus 3. Now, you're going to come across this today and tomorrow. This answer is actually not finished because if we were to take that set of parentheses and go through the factoring flowchart, there is no GCF, there are two terms, and it is a difference of two squares because this is a 2x squared and this is a 1 squared. So for today's and tomorrow's assignment, be very careful that your answer doesn't have a difference of two squares inside of it because then you need to factor one more time. So if we were to factor that 4x squared minus 1, we would get 2x plus 1 times 2x minus 1. And then our x plus 3 that was already there is part of our answer. So this is fully factored. So that whole idea, it needs to be fully factored. So just because you factored it once doesn't mean that it can't be factored again. So double check that you do not have a difference of two squares. They don't all have a difference of two squares, but some of them do. Now, one more thing I want to say about the answer is those three pieces can be in any order. So just because my answer says 2x plus 1, then 2x minus 1, then x plus 3, doesn't necessarily mean yours can't be in a different order. As long as you have the same pieces, your answer is correct. Okay, so your word of the day is GCF because you're taking the GCF out of stuff even if you're doing underlining or the box method. Your assignment is factoring with 4 terms part 1, and the next day is going to be part 2. Let me know if you have any questions, and have a great day.